Welcome to 515 Technologies webinar on maintaining continuous compliance with GitLab and OpenRMF Professional. My name is Jen DiDonato, and those who work with me will describe my role as being the unicorn here at the company, when in reality, I am proud to say I am the Director of Sales and Marketing at 515 Technologies. On behalf of the team, we would like to thank you all for your time today. I'd like to take a minute to introduce this awesome crew joining us today. From 515 Technologies, we have Anthony DiDonato, who's the founder of 515 Technologies and our sister company, Critical Design Associates. Plus, he is also one of our principal architects. Also from 515, we have Zach Thurman, who is one of our automation engineering managers. Joining us from SoteriaSoft is their CEO, Dale Bingham. Without this amazing team, this webinar would not be possible. If you would like to connect with any one of us on LinkedIn, our direct links will be put in the chat. All right, so let's quickly go over the agenda. The focus of today's webinar is continuous compliance and how simple it can be with automation. First, Anthony will define continuous compliance, then discuss some of the challenges with maintaining compliance manually. Then my team will discuss and demonstrate the components, infrastructure, and methods that we use to automate as much of the process and paperwork as possible. At the end of this webinar, we will have an open Q&A session, but should you have any questions throughout this presentation, do not hesitate to put it in the chat. Also, if at the end of this presentation you would like the recording, it will be posted on 515 Technologies YouTube channel, which that link will also be placed in the chat. From here, I'm going to go ahead and hand this off to Anthony.
All right. So we're talking about continuous compliance. And what is continuous compliance? It's a proactive approach to maintaining the requirements set forth by your framework or regulatory bodies across the business environment on an ongoing basis. So as a proactive approach, the goal in continuous compliance is to recognize that the requirements always exist, not just during an audit, but as part of a daily operations. With this mindset, the compliance control owner understands that at regular intervals, they're providing evidence that they've been maintaining instead of scrambling to create or produce the evidence reactively. The focus of our webinar today is really around the framework for NIST and the risk management framework. So some of the challenges associated with maintaining a framework, particularly NIST and RMF, you have to provision, scan, report, track, plan to remediate, then implement the remediation, then provide continuous monitoring, rinse and repeat on a repeated basis. But what that entails is a lot of documentation and chaos if it's done manually. We're going to show you how through automation, almost every one of these tasks, with the exception of specific remediations, can be applied automatically using various tools. So aside from the challenge, there's cost associated. So when you think about RMF or risk management framework, you have a few steps to get to the point where you actually have an authorization to operate. And the first one is obviously categorizing your information systems, selecting your security controls, implementing your security controls, assessing them, then getting your ATO, and then moving into that monitoring phase where you're monitoring those security controls. But there's direct cost, and SoteriaSoft actually has a calculator where I'm going to show you how you can use this calculator to figure out what it's costing you today. And then we're going to go into an example, a recent example with the updates from the DISA STIG updates. So if you're maintaining checklists or STIGs in your environment, you know that recently we just got bombarded. So cost across the board is setting up the infrastructure, securing it, importing scans and checklists, creating and upgrading those checklists as new updates come out, either quarterly or mid-quarter. And then you're tracking those vulnerabilities, correlating those vulnerabilities to controls, and then tracking a plan of action milestones, often referred to as a POAM. So I'm going to pull up this calculator and show you how you yourself can go and calculate what it's costing you today. So this is on the SoteriaSoft website. The link will be in the chat as well. And you can fill out this calculator with a few different things. I'm not going to go through every line item, but assume what your hourly rate is for a cyber resource and a cyber lead. And then from there, you look at the number of SCAP scans and checklists. Sometimes they're in the hundreds, sometimes they're in the thousands. So your numbers will vary. And also keep in mind, if you're doing multiple system packages for your ATO, those are going to affect the numbers as well. And then how often you're upgrading those checklists and how many hours you're spending tracking vulnerabilities, correlating those vulnerabilities to the NIST controls, and then tracking your POAM entries. The reason we offer this calculator, or the reason SoteriaSoft offers this calculator, is to help you quickly justify how valuable automation really is. And what we're going to show you turns months and sometimes years worth of work down to minutes. So it's pretty amazing stuff. I'm very excited about it. Just to give you a little bit of an understanding of the cost, just recently, so this is public.cyber.mil, and we have all the downloads for the STIGs, and you can notice here that I have 100 entries shown because that's the max. But on August, from in the past 30 days, you could see how many updated STIGs there are. So you can imagine if you have even a couple hundred assets in your environment, updating these checklists for every app and updating the STIGs for every environment is a pretty substantial amount of work. So if you haven't checked and realized what kind of impact the recent 30 days have had, you might want to take a look at this link. And if you do so, show 100 entries and then sort by the date that it was updated, and you'll get an idea of what kind of impact you're going to have in the next 30 to 90 days. So when we're talking about implementing automated continuous compliance, there's a number of different components, and there's obviously a lot of acronyms when you're dealing with government systems or even just adopting a framework that has been adopted by government systems. So we're going to talk about the policy associated with the framework, building out that infrastructure, your Windows, your Unix or Linux, your workstations, and then applying those policies through your STIGs. And then monitoring that system through scanning with systems like ACAS or Nessus. Some are using Rapid7 and other tools like that, HBSS. But effectively pushing out your policy and then scanning to make sure that you're maintaining that compliance. And then from there, you're going to go capture your vulnerabilities. You're going to assess those vulnerabilities, and then you'll update your status, plan, and schedule. Then deploy your remediations for any vulnerabilities found, and rinse and repeat. So I want to define a couple of acronyms. I'm sure most of the folks on this call have heard these before, but you have CIA, which are your security categorizations. So confidentiality, integrity, and availability. These are important terms when we start to look at the OpenRMF reporting capabilities. And then you have your system security plan, your STIG, which is a security technical implementation guide, your SCAP scans, which are security content automation protocol. I don't need to read each one of them to you, but we're going to talk about a lot of these things. And the reason it's important is if you're operating in this space with maintaining compliance with a framework, particularly RMF, these are all terms that are very common, and these are probably points of work efforts. So you're spending a lot of time maintaining your POAM, your risk assessment report, your security assessment report, and then mapping your security controls. So these are things that we're going to show you not only how to maintain from a compliance reporting perspective, but how to gather all these artifacts so that you can submit them to your GRC platform. And naturally, if you're doing these things manually, we're going to show you how we automate all of these things to maintain and minimize the amount of people required to do the paperwork and a lot of the repeatable tasks, and allow them to free up to do the remediation where necessary. We're also going to show you software development lifecycle components of risk management. And if you're familiar with software development, you have developers in their IDEs checking out branches of code, pushing them to the repository and merging, typically triggering some form of pipeline to then build, test, and then release to dev, test, prod, whichever environments you might be maintaining or more. It depends on the swim lanes, the enclaves, things like that. But we're going to show you how to add container scanning, dependency scanning, secrets, static application security testing and linting, as well as dynamic application security testing. We're not going to demonstrate API fuzzing, and then monitoring and reporting into one consolidated interface. So before we move into demos, this will be very demo heavy. I will promise not to PowerPoint you to death. We're going to go over a few things. The demo environment for the automation is what I would call a prototypical environment. We have our Windows systems and our Linux systems. We have Windows Server 2016, 2019, 2012, as well as Windows 10. And then on the Linux side, we have several Red Hat versions, as well as some Ubuntu editions. And then from an infrastructure perspective, we're using GitLab and a few other tools. So one of which is the GitLab runner. We're also using Ansible, some Python, some shell scripting, some PowerShell, as well as the OpenRMF Pro and Nessus. And those are our infrastructure components that are being used. Some of these are running in Docker containers, so that's why they're listed on the Docker host. Okay, so first and foremost, every time you hear me mention OpenRMF, I'm speaking about OpenRMF Professional and not the open source version of OpenRMF. So if you hear me just abbreviate to OpenRMF or OpenRMF Pro, everything we're doing is automation related, and we're relying on the APIs. So just for clarity, if you're familiar with OpenRMF, I'm only speaking about the Pro edition throughout the entire webinar, as are my colleagues. So I want to walk through what we're going to demonstrate for you. So continuous compliance automation pipelines, this process is relatively straightforward and very much abbreviated because we needed it to all fit on one slide. So first, we're going to download some Nessus scans and then upload them to our OpenRMF Professional. And we're doing this to get a list of hosts. So we're going to use the upload and Nessus scan to get a list of systems to scan. Then we're going to trigger a pipeline to run a SCAP compliance checker. So that's a DISA STIG scan to scan the systems and upload those results to OpenRMF Pro. Then we're going to trigger a pipeline to deploy the STIGs. So imagine this is the initial provisioning. Someone built these boxes and we're going to scan them and then STIG them all through automation. So we're going to move the Windows devices into the right OUs, and we're going to use Ansible to deploy the STIGs to the Red Hat and Ubuntu boxes. And then from there, we're going to trigger a pipeline to scan them again, meaning we deployed them, scan them, STIG them, and then trigger the pipeline again so that we can then upload those systems. And this can be used to continuously maintain a system that may or may not have been moved into the wrong OU and never put back, or someone made a change, so that you can continuously keep that process maintained. And the way we're going to demonstrate that is through a series of sub-projects in a single project in GitLab. All of this automation does not require OpenRMF Pro, but we're basically automating the process of creating all the artifacts that you would normally use to manually maintain your compliance. So we'll walk you through the setup, the reporting, which is also automated, including email reporting, how we deploy the STIGs, how we do the SCAP scans, how we do the ACAS/Nessus scans. We're using Nessus in this situation. We're not going to go over the Docker images, mainly because those were just used to build some of the automation. And then we'll walk you through the SCAP compliance checker scans. All of these are pipelines that are going to run in tandem or with dependencies based on conditional logic. So in the demo, we'll show you the environment setup, STIG deployment, scans before and after, as well as automated upload to the OpenRMF Pro API. That demo is going to be triggered by quite a few things. So we're starting off with GitLab. There's some Python, some PowerShell, Ansible. We're using the DISA SCAP compliance checker or SCAP SCC tool. We're also using Nessus automation, as well as import and export into OpenRMF Pro, and then the OpenRMF Pro environment. So there's more than just one tool. All of this automation here works independent of your GRC system. We are going to show you a lot, and we will have a lot of time at the end for questions. So with that, I'm going to hand off to you, Zach.
All right, thanks, Anthony. All right, to get started, we'll go ahead and take a look at our infrastructure first to see how that's set up. As Anthony already mentioned, we're using Nessus to scan our hosts in our environment. We have 8 test machines, for Windows and for Linux. You can see that we're scanning 8 hosts here. So these scans, as Anthony mentioned, are being used to create host files that the SCAP Compliance Checker tool is then using to actually run the scans on the systems. The reason for that is when you deploy SCC and want to do your scans, there's different executables that are required for different operating systems and also different versions depending on if you're using Linux or not. For Windows, there's just one executable, but if you use Red Hat 7, it's a different executable than Red Hat 8. So you need to make sure that you use the right one because the 8 version won't install on 7. So we have that defined, and we'll show how that's all working in a minute here. And then for our infrastructure for Active Directory, we have our 4 machines here that are just in our staging OU right now. And when the PowerShell script runs, it will move these systems to the correct OUs to get the GPOs applied for our STIGs. And our STIGs are defined in our group policy management here. So you can see our staging OU already has some STIGs applied, just some basic ones. And then when they get moved into the server OUs, they get the actual server STIGs applied or the workstation STIG. So going out to our pipelines, I'll quickly just go over the reporting one because we won't see that one too much. That will mostly get covered when Dale is presenting because he'll be showing the email that gets sent out at that time. But what this will do is it'll go out and query the OpenRMF platform for all the data that it has out there. OpenRMF has a lot of APIs that you can query for information. And it'll go through and just run this single job here to send the report. It'll pull down all the information that we can find on the history that we've uploaded to OpenRMF and produce visuals based on that history via an email. The scanning pipeline and the STIG deployments pipeline are the 2 main ones that we're going to be looking at here. The scanning pipeline, if you take a look at the pipeline here, so we already have ran this and we have data staged in OpenRMF because this pipeline does take about 10 minutes to run to actually do the scans against all 8 systems and upload them to OpenRMF Professional. But the first job here is going to be to grab the Nessus scans via the Nessus API and download them, and then upload them to the OpenRMF Professional dashboard. So you can see here, we have one system package that has quite a few category 2 vulnerabilities that are currently open. That will change, and we'll be able to see that change dynamically when we upload new checklists to this system package later in the demo when Dale is presenting. But the vulnerability patch scans can be found under the patch vulnerabilities here. And we can see all the Nessus data that was uploaded from the Nessus scans that we did. And we can also see the hardware associated with each system, which is the API that we're using to create the host files. So you can see here, each system is associated with a OS, and then it generates the host files based off of the operating system found for each system. So that is the second stage here to create the host files. And then these host files are used in the subsequent jobs for Red Hat, Ubuntu, and Windows to actually conduct the scans against each system. And if we go back to the repository here, what the pipeline is doing is it's looking in the SCC directory for the particular operating system that's going to be scanned. And then it also takes a look at the OS version. So whether it's 7 or 8 for Red Hat, or Ubuntu has a couple different ones as well. And then it'll copy this installation file to the system, install it, and do the scan. The reason why you have to split it out for the Linux systems is because there's no remote scanning capabilities with the SCAP scanner for Linux. Unfortunately, Windows does have remote scanning capabilities using your domain credentials, as long as the credentials that you're using has administrator access on the systems. But the scans for the Linux machines have to be done directly on the systems. And like Anthony mentioned, we're using Ansible to do all that. So once the scans are done, it'll be uploaded to OpenRMF, and we can see here, if we go back to the system package and we go back to the system dashboard, that there are checklists down here that we've already uploaded from that previous scan, the associated scores with each checklist. So we'll see those numbers get updated when we run the scanning pipeline again after we deploy our STIGs. And I do want to mention that all these pipelines can be scheduled via the schedules tab here. If you want to do like a cron schedule on once a day or once a week for these particular pipelines, they can all be scheduled, but for our purposes for the demo, to make it easier, we just are kicking them off manually. And then out here in the STIG deployments pipeline, this works kind of in tandem with the scanning pipeline. So what would normally happen is you would run your scanning pipeline, that would trigger a pipeline over here for the STIG deployments. And then your STIG deployments would deploy your STIGs out to your machines. And then once the STIG deployments are finished, it would then kick off another scanning pipeline. So if we take a look at this pipeline, won't kick it off just yet, but we can take a look at a visualization of it before we kick it off. What it'll do is go out and download the artifacts from the scanning pipeline to grab the host files that were created instead of recreating them in this pipeline. And then it'll deploy the STIGs to Ubuntu and RHEL. It has the very similar setup to how the scanning pipeline is. You have your OS folder and then your version folder under that. So we deploy the correct STIGs to a particular system. And those STIGs can be found, the Ansible playbooks for those can be found on DISA. They're publicly available and can be downloaded, as well as the GPOs that we have in our environment. And then the move computers job is used to move our Windows systems to the correct OU. Once they're moved into the appropriate OU and they've been checked that they're in the correct OU, they are rebooted to make sure that the GPOs get applied. Typically, you wouldn't reboot them. You might just do a GP update on them. But for our instance, since it's just a demo environment, we're rebooting them to make sure that the settings get applied. And then, like I said, after the STIGs are deployed, it's going to trigger the scans. So what we'll do before I kick off this pipeline is we'll go out here and we will sign into the W16 server. You can see that I don't get prompted for a banner like you typically would if a STIG was deployed to this machine. We'll see that change here very shortly once I start this pipeline, because that's one of the first things that it'll do is move our Windows systems in the correct OU. So you can see there it's already running. And we can probably refresh this, and they've probably already moved, and they have. So if we go to the server 2016, we can see our W16 server in there, W12 in there, W19 in there. And how we're doing that is we just have a hash table in the PowerShell script. You could do a CSV or however you want to do it to basically map a subset of the string to a particular OU, and then move them to the appropriate OU that way. And now if I send it to the W16 server, it should already be up and rebooted. We now see a banner that displays the STIG default. So now if we go back to OpenRMF, do want to show just one thing before passing it back to Anthony here. Inside of your checklist, you also have a POAM. There's other things that are going to be shown when Dale goes through it, but we have a POAM that's already been generated that has that pulls all the information from the checklist that we've already uploaded, and we should see these numbers update as well. So with that, we'll pass it back to Anthony because these pipelines are going to be running for about 8 minutes for this one, and then the scans again take another 10 minutes. So these will all happen in the background, and we'll see the changes replicate when we present again later in the demo.
Yeah, thanks, Zach. All right. Well, that demo is in process. So while he's doing that, I'm going to show you another demonstration. So we talked about, system security, kind of that hard outer shell configuration management, all of that, including the scans and reporting being automated. That's what Zach was talking about. I'm going to show you how to automate and integrate security into your software development lifecycle. I'm going to show you a couple of things, some separately and one working collectively with all. I'm going to include secrets and I'll explain those, static application security testing, dependency scanning, container scanning, and dynamic application security testing. For each, I'll be using GitLab's integrated tools, which are effectively templates for open source projects that are included as Docker containers, as well as pre-configured settings to automatically determine the type of code in your repository. So I'll start out with secret scanning. The first thing to understand is what are secrets. If you have, source code management repositories in your environment, like we do here with our GitLab instance, it's possible that credentials could be stored in that repository accidentally or even intentionally due to laziness. So here you can see I have a JSON username and password combination. This is staged out naturally. We have a fake API key in here. And we also have a fake private key, which I purposefully manipulated so that it wasn't legit. And then I have a pipeline. And you'll see this all working in concert, but I just want to show you how simple it is to get secret scanning enabled on your pipeline. So with GitLab, if you have your repository and it has all of your files in it, as I was showing you, you can just add this template to your pipeline and it'll produce a very usable report. And that report will basically tell you, which you can also export, all of the different findings. So here you can see that there was a JSON web token detected, and this was based on a CMG generic JSON web token. So this is a custom rule that I created. And then from there, I created an issue so that we can track it from a development perspective. So enabled secret scanning, found some components, and then I can assign those to the developer or the risk management team. It's a pretty simple process. If you want to take a look real quickly how easy it is to customize that, I just use a regex in the form of a TOML file, which is just a markup file. I created 2 custom rule sets, and in this case, I just look for generic JSON web token. I'm looking for the strings JWT underscore token, secret, and bearer. And then I'm also just looking for basic password configuration. So I'm using the word password, passwd, whatever case insensitive option you want to use, so that when it's reported, it'll be reported as custom generic password or generic JSON web token. I can create as many rules as I want above and beyond the support that's already there for things like AWS or Azure, you name it. In the background, it's using Git leaks, which is a pretty common platform. So that's secret scanning. I also have another pipeline here for container scanning. So all I'm doing is providing the path to a container, and then I'm incorporating the security scanning template for container scanning, which will also map out dependencies that are associated with the requirements or configuration of the Docker file. So if I go into that repository, you can see that in this folder, all I have is a pipeline, and I'm using this to basically scan something that already exists in a different registry. So when I run that pipeline, it runs very quickly. It scans the environment and then produces output. And that output, it's relatively well formatted. The problem is it's very difficult to, add this into a system in the current format. So what we do is we have this integrated with GitLab, and it allows us to get a very effective and manageable set of vulnerabilities. So you can see here that I have my container scanning findings as well as dependency scanning. So if I look, dependency scanning found nothing. If I look at container scanning, I found specific dependencies in each and the relative CVEs associated with it. So if I were to click on those, and I know that these are critical, and maybe I just want to look at criticals, I can then go and assign these to a different team and create an issue straight from here, it's very easy to do. It gives me all the information that I need. So I have built-in scanning and vulnerability management right here in my own platform, in the same platform. Now you've seen containers, you've seen secret scanning as a quick demo. I also have a complete pipeline where I'm actually pushing to a production environment, where this is a staged production environment. So I'll just walk you through that pipeline very quickly. from a visualization perspective, you can see that we have a test phase, a production phase, and then after that, I'm doing some dynamic application security testing with OWASP-ZAP or OWASP-Z attack proxy. When you see here, because I added the template for static application security testing, which you'll see, I'll go back to in a minute, it has all of these linters associated with them. And then it also has secret detection and container scanning added. And what that allows me to do is say, if any of these types of code, whether I'm using Go, if I have, JavaScript, Python, Node.js components, Java, anything that's in there, it's going to go and find those files and then apply that scanner to it. And it's very easy to implement. So I have 3 to 4 different stages. I have a test, production, and then a DAST stage for dynamic application security testing. I've specified my Docker containers, which we saw before. I set my secure logging level to debug, and I specifically targeted the URL of the production system, which is here. And I'll show you that in a minute as well. In each stage, I'm just running some basic things to deploy the app. I'm using the DPL tool, Travis CI. So I'm doing some basic commands, deploying the tool to Heroku because it's free. And then I'm incorporating all the built-in security tools, which in this case are in the form of templates. So dependency scanning, SAST, secrets, dynamic application security testing, and container scanning. So all of these will run in my pipeline as it pushes to production. So when that pipeline runs, each of those tests will occur, and then I have security gates. So if they were to fail, I could allow them to fail or continue. So you'll see here that there were findings on the container scanning, and there was also some dependency scanning findings as well. So I'll go back and look at the vulnerability report for that. But post deployment, we're continuously actively attacking the system in a passive way. So I'm actively performing passive scans on the system. And you can see that each test that's performed, I either get a pass or a fail, and it tells me which one I used, which test I performed by triggering the OWASP-Z attack proxy to target my system. So what that produces in the end is the vulnerability report. Again, same idea. I had my criticals first, my high, medium, low, unknown, so on and so forth. And then from there, since we already know secrets, we don't really care about that. Let's go look at DAST and see if we found anything. Okay, nothing. Container scanning, this is a different environment. Nope, nothing. And then dependency scanning. And we'll change this back to all status. So here we found that, there was a critical finding in the static application security testing using the Bandit SaaS tool and 3 others. So if I click on that, it'll tell me specifically which file has an issue. I have this integrated with Jira so that I can immediately assign it to a backlog if I need to. But it'll actually tell me specifically and in which file where I'm having a problem. So here the finding is, hey, you're using an unsecured deserialization process, which in this case is Pickle. There are slightly better ways to do it, but I purposely implemented these to get a finding. Also down here, even though it's not flagged in this finding, you'll see that I'm running debug equals true, which is a big no-no. So that'll show up in my SAS scan as well. So that's just a quick rundown of how you can implement DevSecOps tools right from the GitLab platform to get most of the vulnerabilities about your software development pipelines or your source code management repositories. And with that, I will move on back to the slides. So we talked about a lot of different things. So now that we've worked out a lot of the automation around software development life cycles, as well as infrastructure automation and artifact creation, Zach demonstrated how those components can now be uploaded directly into OpenRMF Professional. And what we're going to do is turn it over to SCAP, particularly Dale Bingham, to give you a full rundown on OpenRMF from SCAP. And remember, we're talking about OpenRMF Professional, mainly because we're using APIs for automation. So with that, I'll hand it off to Dale.
All right, thank you, Anthony. Let me get my screen. Get my screen to collaborate. We should be good. All right, there we go. So yeah, so we're going to talk about our software, our flagship software, OpenRMF Professional. This has been 20, almost 20 years in the making. We were beginning this journey back in 04 through 2018, and we started putting our we stopped complaining and started putting our hands on keyboards, working to automate this. So if you've dealt with any of the things that that Zach mentioned, SCAP scans, checklist, manual checklist, audit compliance scans, patch scans, compliance, or any of the alphabet soup letters that Anthony really went through, your SSP, your SAW, your RAR, your POAM, trying to get all of that to be correct and trying to get all of that collaborated across your team, whether it's a team of 2 or 200, is super hard to do. So what my team ended up doing was basically taking this. If you know the RMF or FedRAMP, this is probably a very similar view. You have that nasty, disgusting STIG viewer that DISA put out, whatever, 18 years ago, 20 years ago, and still hasn't really updated. You have multiple Excel spreadsheets. Most people have 4, 5, 6 spreadsheets and PDF reports. You could have PDF on your patch vulnerabilities from, like Anthony said, Nessus or Rapid7. I used to have a checklist that just tracked what vulnerability numbers changed, critical, high, medium, low, what numbers changed, when did they change over certain dates. Keep that updated, keep my POAM updated, keep my my SSP, all my security stuff, my test plan, try to keep all that updated manually is massively stressful. So what we ended up putting together was an automation engine around that, and really telling you to please stop doing this, please stop doing that, and get something that's more automated. That's what we're going to show you here in a minute. So our goal when we started this whole process, our goal was to totally revolutionize RMF, FedRAMP, and cyber compliance processes in general, using automation. You saw, we have a similar thought process with the other group on this webinar. Automation would be key to manage this. So better accuracy, stop all the manually intensive labor, stop all the spreadsheets, stop going through, getting a master's degree in Microsoft Excel just to figure out what vulnerabilities you have open and how does that apply to your controls and your CCI and all the other things. Eliminate paperwork. Our motto here is do the work, automate the paperwork. So our OpenRMF Professional works to automate the paperwork. Stop doing the one-off spreadsheets. And the API for integration. About a year ago, we came out with the API that Zach has been working with us on, and Zach has actually helped improve and expand on with us and working back and forth. API for integration. Do not create another silo. DoD, federal government, even state governments have enough silos. OpenRMF Professional brings in all your information, and then you have an API to interact with. So that could be information, that could be information such as your SCAP scans, like we just talked about. It can be audit compliance scans from Nessus, ACAS, Nessus, Tenable Nessus, or Rapid7. You have other vulnerabilities. You can have software vulnerability scans, SonarQube, Fortify, things of that nature. You have container scans you can map in here. Any vulnerability that you can use, pull that in, pull in your patch vulnerability scans, figure all that information out, and put it under a single source of truth, a single pane of glass that you can jump in and say, okay, for my ATO, for my system package, my ATC, my type accreditation, I want to be able to go in there and see everything that's going on, who did what, where, when, and why, where do we stand, link it up to Jira or ServiceNow to create tasks off of it, all that information. Click some buttons to generate compliance, click a button to download and generate my SSP, my SAR, my RAR, and have a live POAM. So that's really what we're going to show you here. This is, like I said, this is over between Dave Gould and myself and a couple other people. This is almost 40 years of experience in doing this manually combined, and banging our head against the wall, getting a T-shirt that we were there. We have the battle scars. We need to automate this because our adversaries are, quite frankly. So OpenRMF gives you structure, confidence, trust. It also gives you consistency. It lets you map your processes and your tools to what you want to do, or you can adjust your process policy, things of that nature, and have a consistent way for you and your whole team to actually tackle this RMF and FedRAMP process. So who's it for? You see the list in front of you. Cyber folks, there's probably a mix of them on here today. Cybersecurity professionals, we just got off the a conversation earlier with ISSO and ISSM group. So those groups, absolutely, they see the value in this. Project manager, program manager, C-level groups. We've had people at like CIO, deputy CIO level groups, even sysadmins, developers, and analysts that are filling out the checklist and tracking this, or assessors, people that come in and do the actual third-party assessment. So that's really giving you the foundation of what we're going to do and what we're going to show you. I'm going to go ahead and switch my screen real quick. I'm going to do a demo. If I can share my screen. I'm going to do a demo. I'm going to stop sharing this, and I'm going to share my other. There we go. I'm going to share my other screen here real quick. Can you see that, Anthony?
Yes, sir.
All right, perfect. All right, so this is OpenRMF Professional. Thank you. OpenRMF Professional will let you come in, and it basically helps you manage your system packages, your ATO, like we talked about, type accreditation, things of that nature. If you've ever tried to manage 2, 3, 4 of these at a time, you know it's massively hectic, and it's a big pain in the tail. So when you come in and you log in, you immediately get your dashboard. It gives you a list of all your system packages, the type, RMF and FedRAMP. It gives you your information here. There's role-based access down to multiple levels of each package. So if you have no access to it, no role at all, you don't even see it. This is a collaborative environment. This is a server-based, web-based collaborative environment. This is not something you install on a desktop, something you would install locally on a VM or a server. We like to say right now, usually when we do these demos, this is not a software as a service. That's not what this is. We do not want to host everybody's vulnerability data. This is software you can pull down and run locally. You can even run this in a disconnected environment. I'd say over half of our customers do that. So you log in, you see all your system packages. You have built-in notifications across the top. So team notifications, your team gets notified when something happens in your package. Checklist got updated, upgraded, patch vulnerability, POAM, new compliance. The package you inherit information from just updated. Go run your compliance again, things of that nature. We have a bunch of reports. We'll probably only go into a couple. And then we have templates, like Anthony talked about. These would be your DISA templates. Think of a template as a checklist that isn't filled out yet. And there's ways you can boilerplate and pre-fill those out, lock vulnerabilities, things of that nature to get your team to only edit the data they need. So we have all that information. What I'm really wanting to show you is this one right here. This right here is what Zach set up. If I click into that, like he said, this is your package, your system package dashboard. So it gives you your checklist score. And I'll note here in a minute what the numbers were. This will give you your checklist score, your patch score. Your checklist score would be all Cat 1, 2, and 3 vulnerabilities that are open, and then the status of all vulnerabilities across all checklists. I used to track that manually. And even for 15 or 20 checklists, that was a massive pain. And I used, as soon as I saved my spreadsheet, I was wrong because something got updated. So you have that, you have your patch score, and then broken down by device. That would be your patch vulnerabilities. You have your other details around it here, and then your list of checklists. Whether you created it from within OpenRMF, whether you use our custom checklist creator, or you uploaded your raw, you could literally upload your raw SCAP results or CIS Audit Compliance Scan results, create a checklist that comes in here right there. All your checklists are in here. And then we have other information, there's bulk edit. If you've ever wanted, I love this feature personally. If you've ever wanted to edit a vulnerability across multiple checklists and have them all the same, bulk edit. And we keep track of all the changes, and we have built-in configuration management and things of that nature. You get to save all your changes to see who did what. So you have that, locking and unlocking vulnerabilities for false positives, things of that nature. One of the things Zach talked about earlier, patch vulnerabilities. So quickly being able to see your patch vulnerabilities right here. And these numbers are a lot less. I'll show what the numbers were here in a minute. He already ran the pipeline. It already updated, Zach, just FYI, if you want to give me that email. Patch score, software listing, even your software listing and your hardware listing. So not just your hardware listing from your patch vulnerability, but from the host name of your checklist. All the information that cyber folks have to track. What software is on my machine? What's the version that comes off your patch scan? Another big one, Ports, protocols, and services. What are the no kidding ports, protocols, and services running on my machine that I can actually say, hey, these are actually valid ones. If they're on there and there shouldn't be, you need to go turn them off and rescan. So there's ports, protocols, and services, and you can literally, thank you, I got it. You can literally click export and then look at your information here. Boom, there's your ports, protocols, and services Excel spreadsheet. So you have that information as well. You also have a couple other pieces. One would be your compliance. That's another big one. Imagine having to go into every single checklist and every vulnerability and the little CCI numbers that you have no idea what the heck they mean. And they point to other controls and subcontrols, and certain ones you have to meet, other ones you don't have to, but you have to track stuff. Again, doing all that manually. Number one, it's massively time consuming. Number two, it's error prone. We're all human. So get the computer to do all that. We have a compliance engine where you can actually run through, generate compliance to your control and subcontrol, even down to the little CCI level, even down to this little level here, and say, based on this checklist, my status is this for this control, even at that level, and then save it and snapshot it over time. The other one that he talked about would be POAM. So your plan of action and milestone here. So all your POAM items that are in here, going through all the way through, including your checklist, things of that nature, all of those going all the way through. So I talked about my score earlier, checklist score. So let me find that. So this information here was 5472, yeah. So I'm going to go ahead and show that. So if I go back to my what the scans that just happened and some of the automation that kicked in behind the scenes, if I go to my view history, you can actually see some of the information that ran through. Some of the numbers came down a little bit. So you can see based on that, based on your host name, breaking down your vulnerability scores in here, what they were versus what they used to be, things of that nature. So we have all that. You also have information on all your all your checklists, the checklists that were updated, the scans that were updated, things of that nature. All of that comes through with OpenRMF Professional to the point. Let me go back to my documentation. To the point of quickly generating a test plan. Generating user test plan. You can export that out. Generate your test plan. Generate your SAR, your RAR, your system security plan, security assessment report. Just the effect of being able to have all your data in one spot, clicking a button and being able to fill out your SSP with your information here, and then all your controls here, all your controls down here, the numbers that are associated to, what's my status of it. Just having all that in one spot for your whole team to collaborate is massive. It shrinks your timeline. It reduces your stress massively. That's for sure. And it gives you one place for all of your data to be. The information that, let me share this real quick. The information that he just ran from the pipeline generated this email. So it literally just gave me an email. What's my checklist overview? What are my vulnerabilities? Where do they stand? What does the history look like? So green went up, that's good. The orange and the other stuff went down. That's also good. This means not a finding. So all that's in there. So just automation around all of this just helps you track and notice where you are compliance-wise, and gives you back a lot of time to you and your team to go harden your system. That's really the goal here, so as you're going through. So if I can go through, let me close some of these. Go through and go back to this right here. I can basically see even checklist history. I can see right here, system package checklist score. So based on all the automation that just happened, there's a bunch of green that went up, which is, again, that's good. There's a bunch of other stuff that went down. I can actually close this. I can close the not applicable, and I can see what happened on the rest of them. Now, at least I know where I stand, and I know exactly who did what, where, when, and why. There's also a auditing built in. So I know that's the service. So that's the API user. So the API ran through, generated some information, uploaded my checklist, brought my numbers down, increased the good numbers, brought the bad down. I know where I stand. My whole team knows where I stand now. From here, let's move forward on our baseline and track everything and get it done. So there's multiple reports in here as well. There's a whole bunch of information. There's more videos up on our website, but this is just to give you an overview, in essence, of what OpenRMF Professional does for specifically for RMF here, and the automation that kicks in, and the fact that you can run through, literally you can run through, look at my checklist. I can see it needs an upgrade right there. I can see all my vulnerabilities. I don't need my STIG viewer anymore. Here's my vulnerabilities. I can change my status. I track all my history automatically. There's all my history. This is the stuff that just got updated. And I can go through and I can download a CKL file if I need to for submission. I can download an Excel spreadsheet. Even the fact, there's my timer, even the fact of upgrading, all those things that just came out that Anthony pointed to. If I want to upgrade this from 2.8, right, to 2.1 to 2.8, yeah, I can upgrade the checklist. Instead of doing another copy paste, or looking at my ASD STIG or my database STIG, I can rerun stuff, but all the manual things have to be copied, and I'm going to miss something, or I copied one into another one wrong. I literally clicked a button, upgraded my checklist. It's all there. All my information was copied over, and my older one is back here under history right there. Even something as simple as that, especially with something that just came out like a couple weeks ago. So that's in essence the goal of OpenRMF Professional. I'm not going to go into too much other detail. There's a lot here, integration with other tools, things of that nature. But this, in essence, will give you your history. This is my numbers. My numbers were, let me see here. My numbers were 54, 818, and 98 right there. Yeah, those are where the numbers. I did a screenshot before he ran the baseline just to make sure. So that's my total Cat 1 open, Cat 2 open, Cat 3 open for my checklist. And then these are my patch vulnerability scores. So 54, 72. I'm now at 17, which is a lot better. I'm still at 70. Some of these are still high, but at least you've seen that I've ramped them down and we're going in the right direction. All automated. Didn't have to lift a finger. So that's the gist of this, Anthony. If you had anything else, yeah, please chime in. We have questions at the end, but I'm gonna hand it back to Anthony. He can keep going.
Yeah, thanks, Dale.
Yes, sir.
There was one question posted in the chat, and I'm going to answer that live. So the question was, can OpenRMF Pro handle reporting compliance on Kubernetes clusters deployed using AWS auto scaling groups? So effectively using different IPs for the same functions regularly. What we do in that scenario, first before you can upload anything to the OpenRMF API, OpenRMF Pro API, you need to generate that artifact. And the rate at which you do that can be triggered via a number of things. So you could trigger it that when your app launches or is scaled, it triggers a webhook. That webhook could trigger the CI/CD pipeline to automatically run that scan, collect that data, and then have it automatically uploaded to the OpenRMF Pro API. So out of the box, we're using CI/CD pipelines to do the scanning process. And all OpenRMF is doing is capturing that. We're piping the output of that scan to OpenRMF. So if you ran a Nessus scan against your Kubernetes cluster, what we would do is trigger that either through webhooks, through the CI/CD pipeline, or some other integration. So we automate all of that at 5.15, and then we use OpenRMF Pro as that consolidation point for producing your compliance reporting. As Dale alluded to, there's quite a bit. You can definitely upload checklist files from other tools. We're just like, for example, if you're using a different tool to generate your checklist, you can still use those. You can still upload those either manually through OpenRMF Pro or automated using a CI/CD pipeline like we demonstrated using the API. That was a second question. I'm sorry, I forgot to repeat the question. The first question is, if we have another tool that generates our CKL files, can we import them directly to OpenRMF? And the answer to that was yes. You can either do it manually through drag and drop, or you can do it through the OpenRMF Pro API. As an automation engineer, an architect, I prefer never to click and scroll as much as possible. So we would use the OpenRMF Pro API. And just for the record, the OpenRMF Pro open source platform does not have that functionality. Okay. Thanks for the questions. We are going to have an open Q&A as well. So if you have more, if that generates more questions, or really if you want to see anything else, just let us know. I'm going to summarize, and then I'm going to hand it off to Jen to wrap up. So what did we discuss today? That wasn't a question for myself. It was a rhetorical question. So we discussed continuous compliance and really automated continuous compliance. We talked about the cost of doing it manually. If you're on this webinar, you're probably feeling some of that pain already. We demonstrated the capabilities to automate most of that work, but that doesn't put people out of work, right? In a lot of cases, what it does is frees up resources to stop building charts, graphs, spreadsheets, updating them, finding out they're wrong, and then doing them again, and hoping they post them in the right place, or delegate, share, collaborate. It can be chaos. So we try to demonstrate the automated capabilities of that to maintain consistently and repeatable processes. So you're not doing this at a point in time and scurrying to produce results. You can do this anytime, all the time. So we also demonstrated the capabilities to automate the paperwork, right? Dale didn't show everything in OpenRMF Pro, but it'll even build your slide decks. It'll build your export reports. And then last but not least, we've built additional automation to trigger an email with that data. And Zach, if you're ready, I'd just like to show that output very quickly. And the goal here is just to reduce time, reduce the errors, reduce the confusion, and absolutely reduce the cost all through automation. Once you build it, it's very difficult to not see the value and the reduction in those things. So with that, I'm going to hand off to Jen to wrap it up.